Building a JKE cluster in Kubernetes, there's an easier way, and it's all thanks to Crossplane. Today, we're not just going to explore Crossplane, we're starting with a basic approach and then unveiling the proper method for creating your GKE cluster with Crossplane. I have two demos for you today. Now, for Crossplane intro, check out my previous video up here. As for now, let's go ahead and get right into it. If you're new to Crossplane, you'd probably start with building just a bunch of managed resources. It's straightforward, but can be cumbersome for complex setups. Let's take a look here with our first demo. As you can see here, I've got my Visual Studio Code up and running, and I have a demo for us where we're first going to install Crossplane. Now, I'm not going to go over all these steps. I leave it here for you if you haven't done so already from my previous videos. But basically, we install using this shell script, and we install the up command line utility. From here, we can install our universal Crossplane with this command and check that the pods are running. Then we need to install the official GCP container provider. This is where we're going to create a JKE cluster, a resource. And you can check the providers here by running kubectl get providers. Then we need to create a Kubernetes secret. And this is what's going to allow us or allow Crossplane to connect and talk to GCP and create our cluster. You should know how to do this by now. You probably have done this multiple times already. But what happens is, you go into GCP, you create a service account, and then you create a key and download a JSON file like this. And I have that already right here. I'm not going to show it to you because obviously it is a file that needs to be, it's a sensitive file, so you need to take care of it and not check it into Git. So we save this JSON file here as GCP credentials.json, as you can see here. Then you just basically create a secret based on this file, and we're going to call this secret GCP secret. And then from here, we got to create a provider config. So you can see here our GKE provider is created based on the secret that we have here, and you can see the description of that particular resource. Now, the fun part, and this is really where I want to focus on, and that is to first create two managed resources, and these two managed resources are basically a cluster and a node pool. That's how you get a JKE cluster going, very basic. I'm not worrying about networking or anything like that. Just use the default VPC, default subnets. I want to keep it as simple as possible. So how does this work? You guessed it, we have Kubernetes, and Kubernetes is going to deploy this for us using Crossplane. So to do that, we're going to run kubectl apply -f and then our file here. So let's do that. kubectl apply -f and JKE cluster manage resources. And that goes ahead and creates two resources for us, our cluster and our node pool. All right. So to check on this, we can run these commands. So we can run kubectl get cluster. And first I got to spell it correctly. So we go like that, and you can see it's synced already, but it's not ready yet. So Kubernetes or Crossplane is building it for us. The next command is kubectl get node pool, and that will go ahead and check on our node pool, which will again do the same thing. And you'll see that it's not synced yet. So it needs first the cluster to be generated, of course, before the node pool can be generated. Another command, which is important, is to describe this cluster. And you can see here in the events, successfully created or requested the creation of an external resource, and pay attention to the conditions here, the status of the app provider here. You can see that the status is false. It's not ready yet. Okay. And true for syncing. So if there are any errors, they will show up over here. Now, the next command, of course, is to describe our node pool. All right. And similarly here, you look at the events at the bottom, and you can see that it gives you a note saying the cannot resolve references, and references field was empty, and reference resources may not yet be ready, which is our case because we're waiting on the cluster to be generated first. Same thing here. You can get a similar message. You'll see a similar message up here. All right. what does this all look like from a configuration point of view? Very simple. We have our file here that we just used, GKE cluster manage resources. So let's pull that up, and it is right here. So let's take a look at it. You can see that we have two resources really, cluster and node pool. And this is the first demo, and this is the first way when you're first introduced to Crossplane, you'd think, oh, you know what, I'm just going to create some individual resources. They're called managed resources in Crossplane's lingo. And then just put them in one big YAML file like that, and then just apply the file, and Kubernetes is going to go out and create the resources for us, right? Now, while that obviously makes sense when you're starting off, but as time goes on, you'll find yourself in situations where you're building a lot of managed resources and you want to put them all together. And that's where compositions come to play. If you're familiar with Terraform, similar way of doing things is using a module, right? So a module in Terraform will bring individual resources under one umbrella and you can deploy it all at once. So I just wanted to show you this kind of naive way of creating resources, and then we'll dig into compositions and understand how they're all built. But really here to see the file, we start off with an API version, kind, metadata. We give this cluster, the label cluster name is GKE, and gave a name for our cluster, GKE managed resources. And then the magic happens under the spec here. So for provider, and enable autopilot is false, enable intranode visibility is true. If you have any IP allocation policy, initial node count is 1. Our location, US Central 1. Removing our default node pool because we're going to create our own node pool. And writing connection secret to ref. This allows us to create a kubeconfig and store it in a Kubernetes secret. This works for EKS and AKS. Unfortunately, doesn't work for GKE. We'll see when the cluster is up how to log into the cluster. Now, the node pool configuration here, we are creating a node pool configuration, giving it a label, and then under our spec for provider cluster selector, we're selecting the cluster by its label, cluster name JKE, which was defined in the label section up here at the top. So that's how we're tying the node pool with our cluster. Under the node config, here's where we can specify the machine type E2 small. Our disk size in gigabytes is 50, and OAuth scopes can be defined here, as well as preemptible is true, and our node count is 1. What it will do is create 1 node per availability zone. So we're going to end up with 3 nodes. So very simple setup here. Just wanted to show you how quickly this can generate a JKE cluster for us along with a node pool. Let's see how far our setup has gotten to. So let's run kubectl get cluster. We see it's not ready yet. So what I'll do is I'm going to pause the video and then we'll come back when everything is ready. All right, everything is ready, and let's double check. So kubectl get cluster, we see it's ready, and kubectl get node pool, and that one is also ready. Perfect. So now what we need to do is access our cluster. And to access our cluster, I have a couple of variables that we need to grab our cluster name. We can grab it using this Kubernetes command here. So kubectl get clusters and this particular path to get it. And then our cluster location, we can grab that here. All right. And then finally, our project ID, which we definitely know ahead of time, but just to make things easier and simpler, we can do that. And now you can simply echo any one of these variables, and you'll be able to see the output. So cluster name is JKE managed core resources. Cluster location is US Central 1. And then finally, the project ID is Crossplane projects. All right, so we are now ready to run our command here, our gcloud container command. And this is what's going to allow us to access our cluster. So it's going to generate, notice here in my prompt, I'm on Docker desktop, so I'm local. But once I run this command, it's going to go ahead and create or update our kubeconfig to run with our new created cluster in JKE. So if I run kubeNS, I can see the different namespaces inside here. If I choose default, I can see it. I can run kubectl, get nodes, should be able to see 3 nodes, as we can see here. Make this a little smaller. Perfect. So you can see our 3 nodes. If I run kgn, which is an alias that I have, this will show us all the resources and all namespaces that are available to us. So all the pods you can see here per namespace. We basically configured our GKE cluster using Crossplane. And if you're curious to see how that looks, we can quickly take a look at. All right, so here we are inside of the cluster. And we can see inside of GCP, and we can see our cluster right here. And of course, our 3 nodes are created right here. So that's all great. If you're interested in a Crossplane course where we dive deeper, let me know in the comments. And if I see enough interest, I'll go ahead and build a course. So do let me know in the comments. Your feedback obviously is important. Now, you might be thinking there's got to be a better way, and you're right. Crossplane's compositions offer a more efficient method, and let's see what this is all about. If you're familiar with Terraform, as I mentioned before, think Terraform modules. Okay, so let's quickly understand Crossplane components with this slide here. So we can see for Crossplane components, we have multiple of them, and let's explain how they all work. So we have a developer, and this developer is going to access or create something called a claim. So this developer will request a claim, and a composition would be written by a platform engineer. Think of it as a template. And a composition will actually end up creating a composite resource, or XR for short. So if I were to liken this with Docker, for example, think of the composition as a Docker container image, and the claim will go ahead and create a composite resource based on the composition that was written ahead of time. And again, using Docker terminology here, so think of the composite resource as the actual container running, okay? And you'll see that the documentation for Crossplane will tell you that a Terraform module is similar to composite resource. I think of it as both the composition and the composite resource, because when you're writing a module, you're typically almost creating a composition or a template. When the actual template is applied and you have a live resource running, that's a composite resource. That's really when the underlying managed resources are built. And that takes us to the next point here, which is managed resources. That's what the composite resource is going to create, the underlying managed resources. Think of those as things like GKE cluster, node pool, an S3 bucket, and so on. And for all this to work, you got to have a definition, an API schema. And this is the composite resource definition, or XRD for short. What it does, it defines our claim and it defines our composite resource, the API schema for both of them, and how they should look. So basically, from a persona perspective, your developers will only be concerned with the claim. They're only going to write claims. They don't have to worry about anything else. Platform engineers, they are responsible for creating everything else for all of this to work. So this is really important because it ties into the whole idea of self-service for your developers. All they need to worry about is creating the claim. They don't have to worry about the underlying infrastructure to get this all to work. Now let's see compositions in action. We'll use a claim, an XRD, or a composite resource definition, and the composition to set up our GKE cluster. And before we do that, we'll go ahead and destroy our cluster that we just created. So we can do this a couple of ways. We can just go ahead and delete. So if you run kubectl, delete -f and the file that we had here. So this file, that will go ahead and delete our cluster. And I got this error, and it's because I'm in the wrong context. I'm inside the cluster I created in GKE. Of course, I need to change my context to my Docker desktop, and then I can run the command once again, and that should go ahead and delete my container, my cluster, and my node pool that I just created. This is again going to take some time, so we'll pause the video and we'll get back when it's done. Now let's see compositions in action. We'll use a claim, an XRD, and the composition to set up our GKE cluster. Watch the difference in simplicity and flexibility. Now, keep watching to see how this method outshines the previous approach. And if you're interested in a comprehensive Crossplane course, like I mentioned before, let me know in the comments. Your feedback matters. Back to our demo. I'll show you how these Crossplane components effortlessly and seamlessly orchestrate our JKE cluster. So we've deleted our setup, so now we can go ahead and move on. Now, if at the end of the previous setup, you ran into an error that says critical action required, and this talks about this GKE G-Cloud off plugin, it's relatively new, and you need to install this plugin on your local machine. There's instructions of how to do that in this link. All right, let's go ahead and create a composite resource definition. That's what we're going to create first. That's important because this is our template, our API schema, not template, our API schema. So let's go ahead and run that. Cluster xrd.yaml. And that is unchanged because I have deployed it before. And then let's create our composition. And don't worry, we'll go over that, over everything in detail. And then create a claim. So far, the composite resource definition that we applied and the composition we applied, the platform engineering teams would create those. As for the claim, this is, as I mentioned before, this is the responsibility of the developer who wants a Kubernetes or GKE cluster that they want built for them. So they're going to go ahead and create that. Once again, we have a few commands to monitor this, but we've created a new resource called xCluster. This is a new composite resource, and we can look it up by running kubectl get xCluster. And you can see here that it's synced, but it's not ready. And it's using the composition called GKE cluster node pool. All right. And the name of this X cluster is example GKE cluster. If we want to describe it, we can go ahead and do that. You can see here that node pool is not ready, cluster is not ready. So you can quickly see that it's creating both a cluster and a node pool. And more details, of course, down here under the status conditions. This will take some time, just as we saw before, but under the hood is creating two managed resources, the same two we saw before, a cluster and a node pool. We can do the same and describe each one of those components, the cluster and the node pool, just as we did before, since, again, the composite resource is defining these two managed resources under the hood. All right. So let's go ahead now and pay attention to the actual configuration itself. If we start off with the XRD or composite resource definition, this is, again, the API schema that we have for both the claims and the composite resource. So we can see here composite resource definition is, that's the kind. Here's our API group and version. And you can see the metadata, xclusters composition.io. That's the name of this XRD. And then our spec is here. So it belongs, or it has the group. It's going to create this group compositions.io. It has a kind X cluster. So we're creating a brand new resource called X cluster. The plural is X clusters. We have claim names and versions, V1 alpha 1. And it's using open API, a V3 schema. And that's of type object. And you're going to see a lot of this here where you see the properties of spec, type object, properties, parameters. These are the parameters that are going to be used within a claim. For example, location, machine type, node count. If you're familiar with Terraform, again, these are the variables that you're feeding in that the developer is going to assign or create or feed into the claim so that they can get what they want. So location, where do you want this cluster? How big the machine types, so the nodes in this cluster, how many nodes do you need? And then composition ref here is type object, and the properties type, you have a name, type string, and then enum, GKE cluster node pool. A lot of times when I'm working here, I actually just rely on ChatGPT to build this for me based on the composition and claim that I'm building. It's a lot simpler than building this. So here's a composition, and this is really where the meat of our setup and configuration is, because here you can see that we are actually, let me split this to the right and turn this off. And now what we can do is we can compare or put the XRD on the right-hand side. This is our template, and then the cluster composition on the left-hand side. So they're using the exact same API, as you can see. The metadata here, we're calling this GKE cluster node pool. That's our composition name. A composition type reference is the API version is compositions.io v1 alpha 1, which is this group here, and followed by the version here, v1 alpha, that we've defined. So we're defining this, we're creating this. This doesn't exist before, right? So we're naming it. Of kind X cluster, and then the resources that we need. We have two resources. We have a list of two resources. We've got one that we call cluster and one that we call node pool. Okay. And under cluster, we have our base config. And this base config is basically very similar, if not the same, as what we saw before in our individual managed resources. And this you can get straight from the documentation. And what do I mean by that? You can see here, the API version, the kind is cluster, which is here. API version, kind is cluster. Metadata, right? So everything here is basically the same. You can grab that and put it in here. So all this is equivalent to all this. Perfect. Then we move on to something called patches. And patches is where we actually start to update based on variables that you feed in. And these are the variables that the claim is going to define. So what does this mean? In this case, we have a patch from composite field path, and it's looking at the location parameter that comes in from the claim, and it's going to the field called spec for provider location, which is here, spec for provider location. So it's going to override this default value based on what the claim is asking for this particular resource cluster. Now let's move on to look at the node pool. So very similar to what we saw before. Here we got all this is the same as all of that right here. The difference now is with the patches. So again, the patches, they're going to look at the from field is a parameter's location, and it's going to update the for provider location as well, which I don't have to specify here. You don't have to specify it. It will pick it up. And then the from composite field path is looking at the machine type here, and we are updating the node config, and node config is a list. So we're saying node config of element 0 right here and machine type. So we're using the machine type coming from the claim from the developer. And then finally, the node count, same thing. We're updating this node count based on the parameter that comes from the claim. All right, so that's the composition and the XRD. Now let's take a look at the claim. So this is the actual claim. This is what the developer is going to use. Very straightforward. They're using the API group and version that we defined here in our composition. And the X cluster is the new kind that we're creating. And then the metadata example GKE cluster. And we're creating this cluster based on a few parameters. Like I said, location, machine type, node count. And we're referencing our composition right here. The composition reference is this composition right here, so that when the developer runs this, it knows which composition to tie to, and it will go out and create what was defined in this composition. So really, this composition could be a combination of anything. You can add databases in here, you can add storage, you can create whatever you like, and basically expose that to the developer, and it's a self-service portal at this point. They write what they need in YAML, very simple, and they get the complex infrastructure built for them. And the beauty of Crossplane is that this can live in Kubernetes with other application definitions. So you're defining the infrastructure and the application all in one place. All right, let's see how well we're doing here in terms of our cluster. So if we close these to make some room. All right, kubectl get X cluster. And we see it's not ready yet, so we can do the same thing. kubectl get cluster is not ready, and node pool, of course, will not be ready either. So we'll just wait on that, and we'll come back when it's ready. All right, looks like we are ready to go. I can see we're synced and everything is ready. I was running kubectl get x cluster with a watch command, as you can see here, and that gives me an indication that everything is good to go. And once again, we can run kubectl describe x cluster successfully compose resources. All right, let's go ahead and get our cluster name. So kubectl get cluster should give us our cluster name right here. So we can basically update our environment variable with that and run our gcloud command. So let's grab that because the project ID and cluster location didn't change. So that should be good to go. Let's see, I think, oh no, it did change. So we're in US East 1. If you recall in the claim, if we go back to our claim, we're actually overriding the US Central with US East 1. So let's go ahead and change that. That's interesting. gcloud is smart enough to alert us to that. So here, let's change this cluster location to US East 1, and that should give us the right context. And sure enough, we're in the right context. If I look at all my contexts, I can see this is the new one here, the GK8 cluster. And that's what I'm selecting, of course. And I can run KGN. I can see all the resource running here. If I clear and once again look at nodes, I can see that we have 3 nodes running and we've created the cluster same as we did before, but now we're using a composition. And there we have it, a GK8 cluster orchestrated by Crossplane. We've seen both methods and compositions clearly have the edge. If you're interested in more on Crossplane, drop a comment below, let me know. Thanks for tuning in, and I see you next time.